a number of signal transmission system. Okay, these are some examples. you know this is a structure of a signal transmission system: information system, paying system, data terminal, cards, etc. So, and you can see some other signal transmission systems uh, which are used in, yeah, this one is another one. uh, this is the source node, this is a tower, this is another node, these are nodes, and this is the destination. So we have to analyze this type of systems. Okay, signal transmission systems. Or we can think about some network systems. Okay, network system. There are networking system. Yeah, this is a good example of communication network. There are plenty of networks examples available. So we have to analyze this type of systems. How this type of systems? Yeah, we have to understand the structure of this type of network systems. Then we can easily analyze. Think about this system, this type of system. So we have to understand the structure of this type of systems to analyze system. Okay, structure. This is mathematical structures of this type of network systems. This is another source. Source is there, this is the source, these are the destination, and plenty of examples we can see in network system, etc. So we have to analyze. So let us consider a simple network system. It is a bridge structure, bridge system. Yeah, what is the specialty of this bridge system? Yeah, this is bridge structure. If a this is an example of bridge structure. Okay, bridge structure. I think we can see in the Google. That will be more. This is a typical bridge structure of, okay, there are 5 components: 1, 2, 3, 4, and 5. Suppose this is the source node, destination node. Suppose we want to go to, suppose these are what is that, bridges, or paths or junctions. Suppose all these junctions are opened, then we can go from here to here through 1, 4 or 2, 5 or 1, 3, 5 or 2, 3, 4, etc. So this can be, if all the junctions, all the nodes are open or it is active, we can transmit a signal from here to here easily. Suppose this is, let us copy this image and we can analyze using that figure. Yeah, this is the okay. How you visible? Suppose okay. Suppose these are functioning. These are functioning. This is functioning. This is functioning, and this is functioning. Then a signal from here can go through 1 and 4 and reach here. Okay. And if 2 and 5 are functioning, then also this signal can go through 2 and through 5 and reach here. Okay. Or another path is this signal can go through 1 and 4 and reach here. What is other possible paths? Yeah, the signal can go through this 1, 2 and then move to 3, and then it can move to go through the 4 and reach here. And other possibility is, this is a minimal requirement. Okay, the signal can go through 1, then move to 3 and then go through 4 and reach there. Okay, so these are the paths, and there are other paths also. Okay, for example, the signal can if all the nodes are active, the signal can go through all the nodes, okay, and reach the destination simultaneously. So, but keep in mind, these are very important paths. Even though on the other hand, we can think about another situation, that is this is not working. What happens if this node is not working? What happens? The signal can go through either, let us the signal can go through either 1, 3, 5 or 2, 5. The signal cannot go through 2, 3, 4 or 1, 4 because this is not active. Okay, and suppose that, so again these 4 components consist of paths, because using these 4 components the signal can reach here. Okay, and suppose this is not active, then what happens? The signal can go only through 1, 3 and 5. Okay, the signal can only go through 1, 3 and 5. Okay, this is the path of signal. Okay, 1, 3, 5. So this is again it is called path of the structure function. The set of all possible active nodes, are usually called the components of the path set, or this the index of these components are called path set. The collection of the indexes of these sets are called path sets. For example, 1, 3, 5 is a path set, and also 1 and 4 are also path set. 2 and 5 is also path set. 1, 2, 3, 4, 5 is also a path set. What are the components we have taken? If the system is functioning, then the corresponding sets are called path sets. Okay, if the system is functioning, or if the signal is transferred from source to destination, then the corresponding nodes are called belong to the path set. Okay, let us call it as source. Source destination. സോഴ്സിൻ്റെ സ്പെല്ലിംഗ് നല്ലതുണ്ട്. സോഴ്സ് സി ആണ് കേട്ടോ. ഓക്കെ, now think about the situation that okay, think about this. വേണ്ട, ഒരു കാര്യം ചെയ്യാം, വേറെ കളർ എടുക്കാം. കളറിനെ സെലക്റ്റായി കിടക്കണം. ഓക്കെ, അത് ശരിയാവില്ല. Anyway, suppose that one of the component, any one of the component in 1, 3 and 5. Hello? അത് വേറെ അതിന് വേറെ പൈസ തരാന്ന് അവർ പറഞ്ഞിരുന്നു, 5000 രൂപ. ബില്ലടക്കാം മൊത്തത്തിൽ. മൊത്തത്തിലൊരു സെൻറ്ററിലേക്ക് ഒരു സെഷനും, അങ്ങനെ 3 സെഷൻ ഉണ്ടല്ലോ. അപ്പം തകയില്ലേ? ശരി. So suppose that one is also failed, the component among the 3 components 1, 3 and 5. Then what happens? The signal cannot, the system is not working. Okay. What happens? The signal cannot go through the any of the components and the system becomes failed. Okay, so in such situation the 1, 3, 5 is called a path of the system structure, At the same time, it is a minimal path, because if any one of the component is in failed state, the system cannot work. But if 1, 3 and 5 are working, then that consists of path set. Okay, path set of the system. And if any one of the component is in failed state, or if any one of the component is getting failed, then the system will be in failed state. Okay, so in that case, this type of vectors, this type of set of all vectors are called minimal path vectors. Okay, minimal path vectors. And you can see that this is also path vector 1, 2, 3, 5. At the same time, it is not minimal, because even though the set 1, 2, 3, 5 is a path vector, at the same time it is not minimal, because even though 2 is failed, then still the system is working. System is not in the failed condition. Okay, still system is functioning. So 1, 2, 3, 5 is a path, but not a minimal path. Okay, 1, 2, 3, 5 is a path, because the system is functioning whenever 1, 2, 3 and 5 are working. But at the same time, if 2 is in failed state, then also the system is in function state. So in that case, the set 1, 2, 3, 5 is a path set, but it is not minimal. At the same time, think about another situation, that considers path set 1, 3, 5. If component 3 is in failed state, what happens? The system cannot work. So this 1, 3, 5 is called a minimal path. As in the previous discussion, 1, 2, 3, 5 is a path. At the same time, 1, 3, 5 is a minimal path. Okay, I think you got the idea of minimal path and minimal paths. Okay, another concept is cut. You think about these two components. Suppose these two components are in failed state, then what happens? The system cannot work, because the components 1 and 2 are in failed state. And suppose that, and another situation is, one is there, suppose that 1, 3 and 5 are in failed state, then what happens? Then also system cannot work properly. Another situation is, 2, 3 and 4 are in failed state, then also system cannot work. Okay. Another possibility is 4 and 5 are in failed state, then also system cannot work. So these sets, set 1, 2 and set 1, 3, 5 and 2, 3, 4 and 4, 5. So similarly, we can find out other combinations. So this type of sets are called cut sets, cut set of the system. We can say this set as minimal cut. A cut is said to be minimal cut when, if at least one of the components in the cut set is in functioning stage, of if at least one of the component is moved from failed state to functioning state, then the system will be becoming functioning. So in this case, the system is going to functioning. So such cuts are called minimal cut sets. Such cut sets are called minimal cut sets. if any one of the failed component is going to functioning state, then if the system is also going to failed state to functioning state, then we can say that that cut is a minimal cut set. Okay. Suppose this is a cut set, and suppose phi is going, or we have replaced the phi, or we are repaired the component phi, then it will go to as good as new condition, so that the system can work. So 135 is a cut, at the same time it is a minimal cut, because when a component is going to functioning state, the system is also going to functioning state. So in such situation, that type of cut sets are called minimal cut sets. Okay. So we have discussed paths, minimal paths, cut and minimal cut. So based on this minimal path and minimal cut, we can represent any of the complicated systems. Okay, we can represent based on this minimal path and minimal cut. That will be discussed in the next class. I will give you a discussion video to you, no problem. We can represent, yeah, that is available in this PowerPoint. This paths and the minimal path is represented here. Yeah, you know, we have noted that the minimal paths are 1, 4, 2, 3. So in this case, 1, 4, this is 2, 5, 5 anata, 2, 5, 1, 4, 2, 5, 1, 3, 5 and 2, 3, 4. These are minimal paths. Okay, these are minimal paths. The entire system can be represented as a parallel connection of minimal paths. Similarly, the entire system can be represented as a series connection of minimal cuts. That is discussed in the video. I will send you today or tomorrow, no problem. That is discussed in that video. After that, you can understand the concept clearly. So in our daily life, we can see this type of network systems. For example, you think about you need to go to Naduvilal from our college. So what are the possible ways? Either you suppose this is the position of St. Thomas College. This is the position of Naduvilal. How can you go to Naduvilal? You can go to first municipal bus stand, then where is it? SBA, and then you can reach Naduvilal position. Or otherwise you can go to Swapna Theatre through that way, and then Shornur Road, and then go to Naduvilal or MG Road. And the other possibility is you can cross the ground. Okay, you can cross the ground and directly go to Naduvilal. So similarly, we can interpret in our daily life. You can go to Mysore. What are the possible ways? If you want to go to Mysore, what are the possible ways? You can go to Kozhikode, Wayanad, Sultan Batheri, Gundalpeta, Mysore. And otherwise, you can go to Nilambur, Gudalur, then Gundalpeta, Mysore. Otherwise, you can go to Palakkad, Coimbatore, and then Mysore. So there are possible ways. So all that possible ways are called paths. And okay, so this is actually applicable in engineering statistics, engineering mathematics. You can see plenty of journals available in reliability theory. Google. Journals means recent works, recent publication, etc. Plenty of journals in reliability, quality, and safety. Safety, quality, reliability, list of safety journals. Hmm? So plenty of work is available in reliability theory. List of reliability journals. So they are dealing with this type of system structure. They are analyzing that type of systems, and they are finding the reliability of the system. They are finding the importance of the components. They are finding the redundancy application, maintenance, repair. Everything they are doing based on this reliability theory. So these are some, yeah, you can see macroelectronics and reliability. This journal contains the analysis of network systems. Reliability analysis of network system. Macroelectronics reliability journal consists of plenty of research article based on the network systems. Some of journal articles can be downloaded. Let us look what is inside this type of journals. Hello? അത് പ്രിൻസിപ്പളോട് ചോദിക്കണം കേട്ടോ. അതൊക്കെ അവർ സാറിൻ്റെ അധികാരപരിധിപ്പെട്ടാണ്. അല്ല അല്ല, അതെ അതെ അതെ, ഓക്കെ ഓക്കെ, ശരി. So these are some resistor slide they have analyzed. We are using, this is the structure function they have analyzed. Okay, analysis and result are given. So there I think there are several articles in this area. You can study the details in detail, especially for the reliability analysis. So these are all structure of a micro architectures Intel Wiki chip. So everybody are doing analysis using this type of structures. First of all, they will plot the structure, and then they will create a diagram like this, and after that they will separate into either series connection of parallel system or parallel connection of series system. So these are the basic steps involved in the reliability analysis of systems involved in engineering. Okay, so let us stop here. Hello.